I can't believe it. Guess what? I'm doing finish work. Do you believe I'm doing finish work? Finish electrical first. It's only a few days after my surgery, so I'm still doing very light work and I'm looking for excuses to do stuff. I cannot sit idle. But switches are easy. They're all at waist height, sort of chest height. So I can work my way through, and I've got all of the downstairs ones done. And I'm halfway through, more than halfway through all of the upstairs ones. I have one problem, and that is the three-way switch that's in the kitchen upstairs, because I have no clue where the wires go, because this is one of the very few rooms that I didn't wire myself. So I do have video that shows where the wires go. I'm actually going to have to go back and look at video, plus use some continuity tools that I have to figure out where the wires. So a three-way switch should have one wire that goes from one of the switch locations up to the light. Also, one of the switch locations, preferably not the one that goes up to the light, should have power coming into that box for the lighting circuit. My problem is that this switch seems to be serviced by the wire that goes up to the light and has power, and that one over there seems to have power and no wire up to the light. So I gotta figure out what's going on, get it fixed, gotta get on it. And then of course it's outlets, but I'm waiting until I can lean forwards before I do the outlets. Well, I can't believe it. Every single switch is done in the house. There's a lot of switches, a lot of circuits. 27 circuits so far. I've got 3 more to put in, and then the big one over to the sub panel, and then another 6 circuits in the sub panel. It's a lot of wiring, but all done. Every single one of them's done. It feels so good. Outlets are next. I'm a little more than halfway through the finished wiring, and you'll notice the video is conspicuous by the absence of the detail around putting outlets and switches in. It's because it's all so darn simple. It's almost worth not mentioning, except for kitchen countertop circuitry. So I might as well just mention this. So on a countertop, all of the outlets have to be interconnected except for one that is specific to the microwave. They also have to be on a different circuit to the lighting circuit for the room and any wall outlets. So wall outlet over there, wall outlet over there behind that cabinet, and of course light and switches. So there are 2 ways to figure out which wire goes where, because if you're trying to do finish work that somebody else did the rough, all you have is a whole bunch of wires sticking out of the wall and you've got no clue what the heck they all are. And if they're not all connected together, the next thing does not work. So you need 2 things. You either need one of these, continuity gauge, which allows you to hook onto one end of a wire, and it beeps and flashes and tells you if you've got the other end of the correct wire. That's important. What is simpler is a chicken stick. So chicken stick will tell you which wire is live, which wire is dead, and you can power up a breaker that you've put on one end of a wire. I in fact marked all the wires when I put the cables in the wall and plastered. So you power up that circuit and then see, of course, which other end is powered up. To do that, though, you have to have every single wire disconnected in the room, else you can be feeding one thing from another thing and never figure it out. So on the countertop, there are multiple doubles, double, single, double. So one of the giveaways is that the single is most likely the dedicated separate microwave circuit. Doesn't have to be the case. You could have one outlet in a double box that's a dedicated circuit. So this one here, for example, it could be a circuit coming up for the microwave and a circuit coming up for the outlets. Except it's likely, since the wires exit the box horizontally, that this one goes to that one, and this one comes from somewhere else and not this. So by a process of elimination, it's just physical, it's easy. You figure one thing out, that gives you a clue for the next. So it's like eating an elephant. You know, it's an impossible task if you think of the whole thing. But if you focus just on one bite at a time, then it's actually very easy. There's also a few things that electricians do just to drive you nuts. 2 ground wires. This is obviously a double receptacle, but they haven't tied in the power or the common. So it does make you wonder for a moment which is which. So let me get on and do 1 or 2, and that'll be it for this video, I think. So the first thing is the wires are too long. You want space, but you don't need that much. Right, so I'm going to wipe those off. Firstly, the chicken stick. Make sure nothing is live, including the ground. It should never be, but you never know. Whack them off at a reasonable length that allows you to work with the outlet, but not have too much inside the box. Strip them back. The ground, you need to strip a reasonable distance. The common and the power, you don't have to strip as far. And the reason the ground has to be stripped at a reasonable distance is you got to roll it in order to get it on the ground. Ground goes on first, doesn't have to, but I tend to always put the ground on first. Don't think I've ever been zapped, because of course the power's turned off, right? So, and I've double checked. With the ground opening at the bottom, the common is always on the left-hand side. This type of outlet is frustrating because the backstab holes are a little too small. I wired the whole house up with 20 amp 12 gauge wire, knowing that I was putting 15 amp receptacles. But guess what? A 15 amp receptacle won't receive a 12. It'll only really receive a 14 gauge because the hole physically is a little too small at the back. The only difference is, instead of shoving it in and being done, you actually have to curl it and connect it. So power juice goes on the gold, bronze, brass. Of course it's neither. It's just a stupidly coated thin brass looking screw. It's not actually a brass screw. But the problem with these, when you have to twist and bend, is that it takes at least another 10 seconds each to connect. Now I do a couple of things that are a little unnecessary. One is that I make sure all the screw heads are screwed in, and I run a piece of tape around the outside. And it's just because a lot of the time you use metal boxes, and I just do not like the idea of bare wires drifting around in metal boxes. I also don't like to poke things in the back and get zapped. So clean up any plaster that's sticking out. Sort of clean out the hole, shove her back in. So that is the microwave circuit done. When you are putting the tape on, try not to put it over the top of the screw, and also check to make sure that the screws are not so long they're going to interfere with the box. So metal boxes, when the hole closure plug is directly behind the screw where the wire comes into the box, you can hit that with the screw and it busts your faceplate off, which you don't want. Everything requires just a subtle little movement, right or left, to get it vertical, because you can see Alright, cover plate, and we're done, and we move on to the next one. So since I know this is the dedicated one, then it makes the wiring on all of the others a small amount easier. Pick up dust in these black ones, so you get just a smidge of dust and they look filthy. So this is a double outlet. This requires a small amount of additional thought. One ground wire that comes in with the feed tied to the metal box, brought to the front, then tied to 2 additional wires, one for each device, and then the ground continues to the next receptacle. So one of these is the juice coming in, one of these is the juice going out. It really does not matter. So the only complication is that unfortunately all of these are twisters. I don't have any more backstab outlets. So a little bit more time in clearing everything off. Ground's going first, as I've said. Haven't stripped enough on that one. Come over, put both devices. These are tamper resistant. In other words, they've got that little plastic window behind them that is required, certainly in our area. I believe it's required everywhere now. Just stops kids from sticking, knitting needles and screwdrivers into your outlets. And it doesn't even stop them, it just makes it a little more difficult. Which of course makes plugging things in more difficult, particularly the first time you do it. Which is rather annoying. Alright, so what I'm going to do here is bring the common in, both commons, to the, that one's too long. Oh, I forgot, I'm curling these, aren't I? Bring that common and that common onto the same side. It does not matter because all of these are interconnected. See the brass plate that's behind the screws, they're connected together. So what I'm going to do is the right hand, and one of these goes to the black side, and the left hand. So one of the problems I have with this house is we have 10 rooms. I typically will start one of the screws, make sure it's in, and put what holds the alignment between all of them. Like that one needs to go over there, just a smidge. That one needs to go. Fortunately and annoyingly, got to be repeated now for 4 more places just in the kitchen countertops. But I do not have many doubles that have different circuits, etc. behind them anywhere else in the house. It's just the countertops, but it's the upstairs and downstairs kitchen. So that's all done. We'll move on to the next one, do it exactly the same way. So I said I wasn't going to tape doing any more, but I got so peed off doing that last one, I actually went and fetched the proper outlets. So here are the, what you might call the crappy outlets, and here are the very good outlets. The boxes are absolutely identical, both rated for 15 amps, both made by Eaton, both tamper resistant. The difference is residential grade versus commercial grade, which basically means crap and better. Unfortunately, the residential is substantially cheaper. I'm talking $2 versus $5. But you'll be interested, without me hurrying here, just to see what a difference it makes. Because every other outlet in the house are these commercial grades, but Lowe's was out of them when I went to buy 32 more. And I didn't really pay any attention, and I should have done, to the fact that the lower grade was crap. So absolutely terrible. And the difference, even for a non-electrician, will be blatantly obvious in about 10 seconds, right? So the difference is I've got 2 commons. Incidentally, they're both too long, but anyway, 2 commons that both go into, not backstab, but behind the screw plate on one of these screws. And exactly the same, of course, for the juice, that equally is too long. Straight behind the screw plate on that one. Which of course leaves another screw plate available for bringing your black and white over to the other receptacle. So now I can go black straight out of the other one. No stupid twisting needed. And straight into the back of this one. Bring that straight over to the back of there. Again, it's too long. But straight across the back of there. and bring the black across to the back of there. I'm just going to do the other ones again and then move on to the rest of the kitchen. Don't you just love it? All the outlets, all the switches, they're all in. I just realized they're not. There's one. No, there's not. I almost thought I'd forgotten the one tucked behind the chair here. But no, there isn't. And there are a gazillion of these outlets and switches. And they're all, every single one of them, finished. So I've got a little bit of work on the panel to do. A couple of breakers to switch over from standard to arc fault and GFI, so I'm gonna do probably a couple of hours on Monday to truly finish all the electrical. So next is the finish of the bathroom in that bedroom through. Nope, I've done this one. The downstairs bathroom needs to be completed. But look at this, outlets, switches. All right, so Monday, finish the panel work and start on the plumbing.